Here's a video going over each problem in your study guide. Identify which form each equation is in. You got three options: standard form, vertex form, or factored form. The one with the parentheses with the square, that's vertex form, because you can see the vertex here and here. The one with absolutely no parentheses, that's standard form. The one with two parentheses, that's factored form. Next question. Given each quadratic equation, determine how the parabola opens and what key feature can be seen from the equation. All right, so once again, we can tell how the graph opens by looking at our a value, the number in front. If it's positive, it opens up. So this is going to open up. Now, this is vertex form because it's the one with the parentheses with the square plus a number behind it. Therefore, our vertex is what we can see from here and here. So this is going to be showing us a vertex. Our vertex in this case is actually going to be +5, +6. Once again, looking at the very front number, we have a negative. That means this opens down. This time, since it's in standard form, the back number is the y-intercept. So the key feature we see is the y-intercept, and it happens to be 0, -7. Part C, the number right here is a 3. That's positive. The graph is going to open up. Now we are in factored form, which means the things we see are x-intercepts. And the two x-intercepts we have are -3, 0 and +2, 0. Remember, the sign is going to switch when we write the x-intercepts. And then the last one, the front number is a negative, so the graph is going to open down. And since we are in factored form once again, we're finding x-intercepts. And as a reminder that we switch the numbers, so this is -5, 0 and 2, 0. On your test, you're not going to have to state what those specific points are. You just have to identify which key feature can be seen in the equation itself. All right, so this one is asking us to graph. Now, over here it says it's a U-shaped graph. On your test, that will not be there. You have to recognize that this is a parabola, and you can tell it's a parabola by the exponent. Since the exponent is a 2, it makes a U-shaped graph. Once again, this will not be there on the test. You have to recognize it from the exponent. So first thing, we're in vertex form, so I'm going to get the vertex. Once again, we switch our sign, so it's +1. We keep our sign, so it's -2. So our first point we're going to plot is 1, -2. Now, we need to know what our y-intercept is so we can get another point to help us graph this parabola. So the y-intercept always has a y value of 0. So I'm going to go ahead and take my equation, and I'm going to replace the x with a 0. So 0 take away 1 is -1. -1 squared, that's -1 times -1, that's +1. 2 times 1 is 2, take away 2 is 0. So our y-intercept is at 0, 0. Now keep in mind that a parabola has an axis of symmetry. That is a line that cuts the parabola perfectly in half, and it always goes through the vertex. That means if we have a point that is 1 unit to the left, we have another point that's 1 unit to the right. And so now we have 3 points, and we can make our U-shaped parabola. Our next one is an absolute value graph, and what it wants us to do is to graph the absolute value graph. Once again, this is going to be a V shape. This will not be here. You have to recognize it. You can recognize when you have an absolute value graph by the absolute value signs. That's how you know you're going to make a V shape. Once again, we can find the vertex just like the same way we found it with the quadratic. We go to inside those symbols, we're going to switch the sign, so it's -3, and the back number, we're going to keep the sign. So we're going to be at -3, +2. Now, for an absolute value graph, the number in front will act as a slope. So this is going to count up 1, and we're going to count 2 in both directions to make a V. So up 1 over 2. Up 1 over 2 in the other direction. Up 1 over 2. Up 1 over 2. So we have ourselves a nice V-shaped graph. Number 5, write the equation in factored form using the graph. So once again, you need to memorize your forms. Factored form is y equals a parentheses x minus p x minus q. That's what factored form is. You have to know it. It will not be provided to you. So factored form, we need x-intercepts. X-intercepts are the points that touch the x-axis. That is point A and B in this problem. Our P, I'm going to make -2 be P, and I'm going to make 3 be our Q. So we're going to plug it in. So we have y equals a x minus a -2, and then x minus +3. I'm going to clean up my problem because I have a bunch of extra negative signs. So a negative and a negative make a positive. I need to solve for a. To do that, I need to replace the x's and the y with another point that's on the graph. It doesn't matter which one you pick, it just can't be the x-intercepts because you've already used them. So I'm going to go ahead, I'm going to pick a y-intercept. You could pick 2, -4 if you wanted, it really doesn't matter. And I'm going to replace the x's with the 0 and the y with the -6. Now I want to solve for a, so I want to kind of simplify my problem. 0 plus 2 is 2. 0 take away 3 is -3. 2 times -3 is -6, and we have our a, so -6a. We want to get a by itself, so we're going to divide both sides by -6, so a is 1. Now we can write our equation in factored form. Y equals, the a is a 1, then we have our parentheses x plus 2, x minus 3. And this is our equation written in factored form. Number 6, write the equation in vertex form using the vertex 3, 4 and the point 0, -5. So vertex form is y equals a parentheses x minus h close parentheses squared plus k. Once again, you need to memorize your form, which is written here in green. This one's the vertex form. For the vertex, the 3 is the h, the 4 is the k. So I'm going to plug those into my form. Y equals a x minus 3 squared plus 4. Now that I've plugged that in, I need to solve for a. So I'm going to replace the x and the y with the other point that is given. So my y is a -5 and my x is a 0. So we're going to have 0 take away 3 is -3. -3 squared, that's -3 times -3, that's positive 9a plus 4. We want to go ahead and get the 9a by itself, so I'm going to minus the 4 over to where the -5 is. That's going to get me -9 equals 9a. I'm going to divide both sides by 9 to get a by itself, and I get -1. Now to write my equation, I'm going to write y equals -1 x minus 3 squared plus 4. And now I have it in vertex form. Number 7. This time we're given a table of values and they want us to write the equation in standard form. This is the long one that's really annoying. So we're going to start off with picking 2 points. This point here and this point here. This point is our y-intercept, and I know it's the y-intercept because the x is 0. That means this is what we call the c value. The standard form is y equals ax squared plus bx plus c. Once again, you need to memorize that form as standard form. Now we're going to take each one of those points. So we're going to take -3, -4, and the c value is -1 from the table, and we're going to plug it into our form. So we're going to have y equals ax squared plus bx plus c, and we're going to replace them. This is the x, that's the y. So we're going to have -4 equals a times -3 squared plus b times -3 plus, well, in this case it's going to be a minus because our c is -1, so we just have -1. We're going to do our math. -3 squared is +9. b times -3 is -3b, and we have our -1. That all equals -4. We're going to go ahead and we're going to add the 1 over. So we're going to have -3 equals 9a minus 3b. We're going to do that process all over again, but now we're going to use the other point, 1, 4, and the c is still -1. This is the x, this is the y. And I just plug it into the standard form. And now I'm going to replace the y with a 4, the x is going to be replaced with a 1, and the c is replaced with -1. So 1 squared is 1, so I have 1a. b times 1 is 1b. I have my -1. I want to go ahead and get the a and b by itself, so I'm going to add the 1 over. So I have 5 equals 1a plus 1b. So now I'm going to stack these two equations on top of each other. So now we want to do is get rid of one of the variables so we are able to solve for the other one. So to do that, the two numbers need to be the same but with opposite signs. So here for b, I have a -3 here and a +1. The signs are already opposite. So I ask the question, is there a number times 1 that can get me a 3? Yes, 1 times 3 does that. So I'm going to times the entire bottom equation by a 3. When I do that, I'm going to have 15 equals 3a plus 3b. And I'm just going to go ahead and rewrite this equation right here. So now 3b take away 3b is 0, so those cancel out. 9a plus 3a is 12a. -3 plus 15 is 12. Divide both sides by 12 to get a by itself, and we get a 1. Now that I know that a is 1, I can find b by plugging in to one of the equations up here. It doesn't matter which one you choose. I'm going to pick the one with the 5. So 5 equals 1 times a plus 1b. That a is going to get replaced with the 1 that I found. So 1 times 1 plus b. So 1 times 1 is 1 plus b minus the 1. And you learn that b is 4. So the equation in standard form is going to be y equals, the a was a 1, then our x squared, plus our b is a 4, so 4x minus 1, because our c was -1. And that is the equation in standard form. Number 8. So the 8 through 14 is going to be factoring problems. This is what we did the past 2 days. We have 4 terms, but once again, you should always check to see if there's a GCF. Only 3 of the terms have x's, so there's no x GCF. We have a 6, an 18, a 7, and a 21. Sadly, they do not all have something in common. So we can go straight to the box. Once again, for this, we're going to put them in order of a z, like so. So now I'm going to plug the 6x to the third here, 18x squared here, negative 7x, and negative 21. And so now here we got to figure out, once again, the little trick that if this is an x squared, then over here on the left side, I will also need an x squared. This right here is an x, so right above on the top, I need an x there. Now I need to figure out two numbers that multiply to be the 6x to the third. Well, the first one that pops to my mind is 2 times 3. However, 3 times some number gets me negative 7 doesn't exist. There's nothing times 3 that gets me negative 7. So that can't go there. But if I put a 2 there and a 3 here, nothing times 2 gets me negative 7 either. So multiplying by 3 and 2 isn't going to work. Another combination that multiplies to be 6 is 1 times 6. So if I put a 1 here and a 6 here, 1 times negative 7 can get me negative 7x, and 6x squared times 3 can get me 18x squared. And we can confirm that 3 times negative 7 gets me negative 21, that's over here, so I know my combination on the outside is correct. So I can go ahead and now write my final answer of 6x squared minus 7, and then x plus 3. We just have to make sure there's no difference of squares. I notice that I have a minus sign here. So I have to check, can I square root the first term and get a whole number? The square root of 6 is some decimal, so that's a no. So there is no difference of squares here, and this is our final answer. Number 9. We have 8x to the third minus 125. Now this has two terms, 1, 2, and I notice that this has a cube, which means this is a difference of cubes. A difference of cubes uses the formula, the small parentheses and the long parentheses, and to help us with the signs, we use the phrase SOAP, same, referring to the same sign. So the first sign in our problem is going to be a minus. The O for opposite, so instead of a minus, we'll have a plus. And then AP means always positive, so I'm going to have a plus sign in the back. Then the rest of the form is just A, B, A squared, A, B, and B squared. You have to memorize that. That will not be provided. You must memorize your forms. You have a lot of things to memorize for this test. All right, so now we got to figure out what A is. To do that, we're going to cube root each one of these values. The cube root of 8 is 2. The cube root of x to the third is just x. Once again, to figure that out in your calculator, you can hit 3, referring to a cube root, hit the second button, and then hit the caret button. That's going to have this look like, this will be in your screen like so. And then you just type in 8, hit enter, and it's going to tell you 2. Now the calculator cannot do the variables. You have to do that yourself. If this is a 3, it's always 3 divided by 3 is 1, so it's really 2x to the first, but we really don't write exponents that are 1s, so that's why we write 2x. Then I'm going to do the same thing for the 125, the cube root of 125. Once again, you can just type this into your calculator, and then type in 125, and it's going to let you know that the value is 5. Now that we know the A and we know the B, we can plug it into the formula. So our A is 2x, our B is 5. Now remember, this is A squared, so this is technically 2x being squared plus 2x times 5, which gives us 10x plus 5 squared. Now to actually finish the problem, this is going to be 2x minus 5, 2x squared, 2 squared is 4, x squared is x squared, plus 10x, and then 5 squared is 25. And there's your final answer. So this problem right here has two terms, but notice this time it's a square, not a cube, which means we are doing a difference of two squares. This one, we will need to be square rooting the first term and the second term, not cube rooting, but square rooting. However, the square root of 20 is some decimal, which lets me believe that there's probably a greatest common factor here. So the biggest number that goes into 20 and 125 is the number 5. So if I take a 5 out, I'll have 4x squared minus 25. That's because 5 times 4 is 20, and 5 times 25 is 125. Now I can see the difference of squares much easier. This is where I'm trying to do the a squared minus the b squared. And once again, we get a by square rooting 4x squared. The square root of 4 is 2. The square root of x squared is x. So this is our a. For b, the square root of 25. The square root of 25 is just 5. So our form is simply going to be, we write our GCF out in front. We have two small parentheses. One should have a plus, one should have a minus. The 2x should go in front of the sign, and the 5 should go behind. You have now factored with a difference of squares. Be careful. It's very easy to mix up a difference of squares and a difference of cubes. Keep your eye on that exponent to know which is which. All right, this problem has a typo, and in class I have you corrected it, and this should really be an 8. So we have 27x to the third plus 8. We have two terms, but once again, notice how we have a cube here. That lets us know that we need to use our formula, the one with the small parentheses and one with the long parentheses. We use the phrase SOAP to help us do the signs. Once again, S is for the same, so we're using the same sign, so we're going to have a plus. O is for opposite, so then we're going to have a minus. AP means always positive. And so now I go ahead and I fill in the form. A, B, A squared, A times B, B squared. Going through the process of finding A and B, we're going to cube root the 27x to the third. Once again, use your calculator. You type in 3, you type in second, or you hit the second button, and then you hit the caret button. That's going to give you the number 3. And once again, you got to do the variables yourself. It should just be an x, because 3 divided by 3 gets you x to the first. Then we go ahead and we cube root the 8. We just type it into the calculator, and it's going to tell us that b is 2. So we just fill it into the form. So we're going to have parentheses, the a is a 3x, plus b is a 2. Then we have 3x being squared minus a times b, so 2 times 3x is 6x. And then we have b being squared. So just to clean up the problem, 3 squared is 9, x squared is x squared, minus 6x, and 2 squared is 4. And you have your nice simplified answer. 16. So we have a trinomial. That's the one with 3 terms. So I notice that I have a 6, a 28, and a 16. Those are all even numbers, which lets me know that there's definitely a GCF here. It's probably a 2. So I'm going to take a 2 out. So I just divided each of those numbers by 2. Since I have a trinomial, I need to use my box, but sadly, I don't have all the information to fill the box in. This term right here, our A term, is going to go right here in the top left. Our C term is going to go here in the bottom right. Our B term goes out here off to the side, and then we're going to go the A term times the C term. So 3x squared times 8 is 24x squared. We don't know what these two positions are. We got to figure out the combination to be able to do that. So we're going to need to figure out two numbers that multiply to be the 24x squared. And then the same two numbers are going to add to give you the 14x. So I just think of numbers that multiply to give me 24. So I got 1 times 24, 2 times 12, 3 times 4, 3 times 8, and 4 times 6. So trying to figure out which one is going to add up to 14. So that's going to be a 2 and a 12. So we're going to have 2x, 12x, 2x, 12x. So 2x times 12x is 24x squared. 2x plus 12x is 14x. So those numbers are going to go right here. To get our outside numbers, we got to figure out what two numbers multiply to be 3x. That would be 3x and 1x. Now I put the 3 on the left side because I know that 3x times 4 is going to get me 12x. And I know that 1x times 2 is going to get me 2x. And I can see that 2 times 4 is 8. So now all I got to do is just write out them as factors. 3x plus 2 and 1x plus 4. Like so. And you have factored this. Oh, I almost forgot. Don't forget your GCF that you took out. That's part of your answer. 14. We have ourselves another trinomial. And this time I'll notice I have an x, I have some x's, and I have some x's. Each one of these has at least one x, which means I'm going to want to factor out an x from the problem. So each of my terms just has one less x this time. So now I'm going to go ahead and make the box again. So once again, the first top left box is going to be 4x squared. The bottom is going to be 5. Negative 21x will be out here on the side. And then 4x squared times 5 is 20x squared. Since we don't have the information for these two spots in the box, we got to make the combination to figure them out. So we're going to multiply two numbers to get us the 20x squared. And then the two numbers have to add to give us the negative 21x. And so two numbers that multiply to be 20 but get us 21 are simply going to be 20x times 1, 20x times 1. Now, we do see that this is a positive 20x squared and this is negative 21. Both of our signs are going to need to be a negative for this to make sense. Negative 20x times negative 1x is positive 20x squared. Negative 20x plus a negative 1x is negative 21x. So now that we have our numbers all set up correctly, we can now fill them into our box. So the numbers on the outside, we're going to have a 4x on top and an x on the left. And I did that because I know that 4x times negative 5 is going to get me that negative 20x. And then a 1x times negative 1 would get me negative 1x. And I can see that negative 1 times negative 5 will give us positive 5. So I just write out my factors. And I'm done. Well, once again, don't forget that GCF. That x that you took out earlier is part of your answer. Don't forget it. Number 15, one of our review problems from the first test. So this time, we're going to take a look at the top equation first. We're going to make a table for that. So here, our domain says x is less than or equal to 2. So the table starts at 2. It has the little bar underneath the equal to symbol. So I'm going to have a closed circle. And it says x is less than 2. So I care about the numbers smaller than 2, like 1, 0, and negative 1. To get the y values, I'm simply going to plug these into the x. So y equals 0.5 times 2 minus 3. And I simply type that information into a calculator to get my values. And so when I do that, I'm going to get negative 2 when I plug in a 2. When I turn this into a 1, I'm going to get a negative 2.5. When I plug in a 0, I'm going to get negative 3. And when I plug in a negative 1, I'm going to get negative 3.5. So I'm going to go ahead and graph that. So at positive 2, negative 2, I'm going to have a closed dot. At 1 and the negative 2.5, it will be right here. And at 0, negative 3, and at negative 1, 3.5. Now this said x is less than or equal to -2. So it's using all the x's that are less than -2, so it's going to continue this way, and I don't want to forget to draw my arrow. Now I'm going to go ahead and look at the second equation. So this time, this says x is greater than 2. So once again, starting at 2, but I'm going to use an open circle when I plot that point. Numbers greater than 2 are going to be a 3, a 4, a 5, and a 6. I recommend that you use 5 values when you have an x squared type graph, when you have a quadratic. That way you're definitely going to see the U shape of the picture, so you can actually have the correct graph. So we're going to go ahead, we're going to plug in a 2 in for that x, and we're going to use our calculator to do the math. And we're going to get, so 2 is going to be a 2, 3 is going to be a 1, 4 is going to be a 2, 5 is a 5, and 6 is a 10 when I plug it in. Now when I plot the point 2, 2, it's going to be an open circle. And then at 3, 1, I've got a point. At 4, 2, I've got a point. At 5, 5, I got a point. And at 6, 10 is my last point. And that way you can really see the parabola there. Problem 16, factored form. So factored form, once again, is going to be y equals a parentheses x minus p, x minus q. And once again, factored form, you're looking for x-intercepts. X-intercepts are the ones that have the y values that are 0. And so I'm going to make this one be p, I'll make this one be q. So when I plug it in, I would have y equals a, x minus -2, and then x minus 4. I'm going to clean up the problem by dealing with all those negative signs. So a minus and a negative make a positive. Now you should just pick some other point, whatever point you think is easiest to plug in for x and y to find your values. I'm going to plug in the 0 and -8 because I think 0 is an easy number to work with. So my y value is the -8 and my x value is the y. So I'll have -8. My x's are all zeros. Now I'm going to solve for a. I'm going to start with the parentheses. 0 plus 2 is going to be 2. 0 take away 4 is -4. 2 times -4 is -8, so I have -8a. I'm going to divide both sides by -8, so a is a 1. Now that I know what a is, I can actually write the equation. Y equals 1, parentheses, x plus 2, x minus 4. And now I've written the equation in factored form. Remember, you need to memorize your forms. Problem 17, writing something in vertex form. Once again, vertex form is this right here. And you need to memorize it. Your vertex, the -4 is the h, the -6 is the k. So if we plug it into our formula, we'll have y equal a, x minus a -4 squared subtract 6. Once again, when you have a minus and a plus, when you have a minus and a minus, you're going to make a plus sign. Now, we need to solve for a, so we need another point. Our other point has been provided. That's going to be our x and our y. So our y is a 6. Our x is a -2. And so we have -2 plus 4, that's +2. 2 squared is 4, so we have 4a minus 6. We're going to add the 6 over to get a by itself, so we're going to get a 12 equals 4a. And if we divide both sides by 4, we're going to get a equaling a 3. So to write our final answer, y equals 3, parentheses x plus 4 squared minus 6. 18, the last problem. So this is asking us to graph a parabola. that's a U shape. Once again, this little note here is not going to be there for you. You have to recognize it by looking at the square value, at the exponent. So, since it's in vertex form, we can see the vertex. The vertex, we get the x value from what's inside the parentheses. We switch our sign. The number in the back is the y value of the vertex. So I'm going to plot that point. -1, +2. So now that I have my vertex, I need another point. The y-intercept is the easiest one to find. So I'm going to go ahead and find the y-intercept, and I know that every y-intercept has an x of 0. So I'm going to plug it into the equation. And then I'm going to solve the problem. 0 plus 1 is 1. 1 squared is 1, and so 1 times -0.5 is -0.5, and then we have our +2, and then we just combine, and so we're going to get a 1.5. So our y-intercept is at 1.5 on the y-axis. Now, a parabola has an axis of symmetry, which always goes through the vertex, which means if I have a point that's 1 unit to the right, then I have another point 1 unit to the left, directly horizontal to it. Then I can go ahead, I can connect my points and make myself a U.